Okay, so as I was saying, today inshallah we are going to basically learn how to convert binomial distribution to normal distribution. Okay, so oftentimes you will notice in binomial distribution that all of a sudden you will have an extremely large number of trials. Okay, like for example, binomial distribution we apply when we have like 10 trials, 15 trials, 7, 8, 9, 10, so basically trials that we can easily work with. All right, so what you'll notice oftentimes there will be a binomial question, and then the question will say that now the number of trials have increased to 80 or 90 or 60 or 50. Okay, now we can't apply binomial distribution in that case. Why? Let me show you. So basically, let me write down today's date. It's the 22nd of March. Yeah. So what we're doing is, I want you to keep this at the back of your mind. We're doing something called normal approximation, okay, where we take binomial distribution and we turn it into normal distribution. Binomial distribution and we turn it into normal distribution. All right. Now the question is, why do we do it? All right. And another question is, how do we do it? Okay. So let's start with the why part. Okay, let's understand why it is that we take binomial distribution and we turn it into, or we have to turn it into normal distribution. So the answer is very simple. I just explained right now that the number of trials is really large. Okay, and not only that, will be impractical or very time consuming to use binomial distribution. Okay, like for example, if you go back to binomial distribution, the max that we've had to do is probably apply to 3 cases, 4 cases. Like for example, if the question says that, let's say a flight is delayed and you're given the probability, and we're talking about 15 days, the number of trials are 15, and the question says find out the probability that the flight is late at least 12 days. So what do? We take 12, 13, 14, 15. Okay, so just 4 calculations and then we add them up, or if we have to subtract, we subtract it from 1 if the question is asking less than. So that's what we do really. Okay, so we don't have a lot of calculations. I mean, we do have a lot of calculations in isolation, but not as many if the trials are significantly large, like we're going to see over here. So it's impractical to use binomial distribution. Now, like for example, if the question says, so here's an example, that a fair coin is tossed 50 times. So you're tossing a fair coin 50 times, all right? And you're asked to find the probability of getting at least 20 hits. Okay, now since it says at least, that means could be 20, could be 21, 22, 23, all the way up to 50. Okay, so if you work this out, that means probability of x being greater than or equal to 20 means that we want the probability of 20 plus the probability of 21 plus the probability of 22, and then all the way to the probability of 50. Okay, so is it a good idea to use binomial distribution? No. We will most likely get the correct answer, okay, or we will get a very accurate answer, but it's not a good idea to use binomial distribution over here. Okay, so we put a cross there. A good idea would be to use normal approximation, that is to turn this into a normal distribution. Okay, now if we recall the differences, there are two differences. There are differences between the two distributions. Right, binomial distribution is basically a distribution of a discrete random variable. So binomial is basically a discrete random variable. You can see that we have discrete outcomes. Okay, 20, 21, 22, 23, so on and so forth. Whereas a normal distribution is basically a distribution of a continuous random variable. Like for example, we saw earlier height. Okay, so you don't have discrete values of height, you have continuous values of height. And in between two discrete values, let's say 5 feet and 6 feet, you can have any value. Okay, there's no limit to how many values you can have in between two values. All right. Achha, another thing to note is that the more the trials, the accurate the normal approximation. Okay. Now, what do I mean by this? What do I mean by this statement? I'll explain. So in a question, they ask for the conditions of binomial representation of data. So how should we answer it? Okay. So basically, number of trials are fixed. All right. So we have done this, as in we have written the conditions for binomial representation of data. These are your conditions. The number of trials should be fixed. The number of the probability of favorable outcome should be fixed. And just like that, the probability of unfavorable outcome should be fixed. So these are the conditions. These are the conditions to apply binomial distribution. There must also be only two possible outcomes. Probability of one event should not affect the probability of another. So yeah, these are the conditions. And the number of trials must not be more than 30. These are the conditions. Okay, if you can tell me exactly what the question was, so we can see exactly what the answer to that question is. Okay. All right, now, does that answer your question, by the way? Come on. Okay, pretty good. So we're going to see what I mean by this statement. You're welcome. We're going to see what we mean by this statement, that the more the number of trials, the accurate the normal distribution. Okay. So remember that binomial distribution is basically has discrete values. Okay. So I'm gonna use an example. I'm gonna use some diagrams over here to explain what I've written above. Okay, so here is what we here is basically how we learned that the more the number of trials, the accurate the normal approximation. So basically what you see on the x-axis, what you see on the horizontal axis are the number of successes, okay, and what you see on the vertical axis, although I haven't drawn it over here, but what you see on the vertical axis are basically probabilities. Okay, now we know that a binomial distribution is basically of a discrete random variable. Okay, binomial distribution is applied to a discrete random variable, which is why you see discrete values over here. So 0 has a certain probability, 1 has a certain probability, 2 has a certain probability, just like that, 3, 4, 5 and 6. Okay, now normal distribution is basically applied to a continuous variable, like for example height, length, mass, all those kinds of things. Okay, now what I've done over here is that in a binomial distribution, if you're asked to find out the probability of x being greater than or equal to 4, what does that mean? That means you will find out the probability of 4, you'll find out the probability of 5, you will find out the probability of 6. Okay, let's say you're tossing a coin 6 times and you're asked to find out the probability of getting at least 4 heads. That means you will find out the probability of getting 4 heads, 5 heads and 6 heads, and you will add them up. Okay, so basically the area that you would consider are of the bars that I've highlighted in blue. Okay, now if you do the same in normal distribution, so first of all, where do we find 4 on this curve? So 4 is basically right at the center of this line right here. Okay, the absolute midpoint of the bar is where 4 is. Okay, now if I do this on a normal distribution of that means finding the probability of x being greater than or equal to 4, that means what I'm considering is the area of this region, which we know, which we saw earlier, basically represents what? Basically represents probability. Okay, now notice that if we use binomial distribution, okay, look at the, so I'll erase this, but look at the area that I've highlighted in blue. We have, and compare it with the curve, okay, we have some region, some unwanted region, which also we end up which also ends up being considered. Okay, how do I know it's unwanted? Because it's outside of the curve. Okay, and then just like that, if I use normal distribution, then what happens is, again, some unwanted region, that means the gaps that we have between the curve and the bars, they end up being considered. But the good thing is they end up canceling out each other. Okay, Because when you're using normal distribution, you end up considering some region, some unwanted region, okay? And then when you're using normal distribution, you also end up considering some unwanted region, but the two cancel out each other, okay? Now, how is it that the more the number of trials, the accurate the normal approximation? Well, the answer to that lies over here, okay? Now, notice that if we have 100 trials, you can see that the bars are outside of the normal distribution curve, okay? So we have 100 trials and you can see that the bars are, you have a very small area of every bar that is outside of the normal distribution curve, okay? That means if I use normal distribution, my answer will be accurate, but it's not going to be too accurate. Why? Because we won't end up considering some of the wanted area, okay? But again, the wanted area and the unwanted area, which we will end up considering, will partially cancel each other out, okay? Like for example, we won't end up considering this area, but we will end up considering this area, which is not wanted, but the two will cancel each other out, okay? So we will have an answer. It's going to be an accurate answer, but it can be more accurate. How? Notice that if we increase the number of trials, from 100 to 400, now the area outside of the normal distribution curve is almost negligible, okay? It's almost negligible, like it's very difficult to see the part of the bar that falls outside of the normal distribution curve, okay? But what if you take it up to 900 trials? Then you can see that the bars are almost inside, every bar is almost inside of the normal distribution curve. That means the probabilities, if you calculate the probability using binomial distribution or if you calculate the probability using normal distribution, they both will be very close to each other, which is why we say that the more the number of trials, the accurate the normal approximation. Okay, so this was just a bit of a theory. You might get a question on that why is it not accurate or why it can be considered accurate. So just remember, the more the number of trials, the accurate the normal approximation. Okay, so this is, and I'll make another note over here, and that is, the more the trials, the more the trials, the lesser the difference between wanted and unwanted areas. So once again, this was a bit of theory, not absolutely necessary for you to know this, but just remember the key points that the more the trials, the accurate the normal approximation. Okay, now we're going to look at something very important, which is called the conversion. Like, how do we convert a binomial approximation, a binomial distribution, to a normal distribution? Okay, this is something that you must know. Conversions. So once again, keep this at the back of your mind that we're converting from binomial to normal distribution. Okay, and what are the parameters of a normal distribution? Like, what do we need in order to apply a normal distribution? We need to know the mean, and we need to know the variance. Okay, the square of standard deviation, which is variance. Okay, now what are the conditions? Condition number 1, n, which is the number of trials, must be greater than 30. Okay, that means if you're dealing within 30 trials, it's safe to apply binomial distribution, but the second you have more than 30 trials, like 50, 80, 100, it's best that you convert it to normal distribution. Number 2, NP. NP means the number of trials multiplied by the probability of favorable outcome. Okay, NP must be greater than 5, sorry, not 50. Okay, and remember, this becomes what? This becomes your mean of the normal distribution. What do I mean by that? So if you have a binomial distribution, what are the parameters of binomial distribution? The number of trials and the probability of favorable outcome. Okay, when I say parameters, that means what is it that you must know before you apply binomial distribution? You must know the number of trials and you must know the probability of favorable outcome. Okay, with the number of trials or with the probability of favorable outcome, you can work out the probability of unfavorable outcome, since there are only 2. And just like that, reading the question, you can figure out what are the number of successes that you want. Okay, but if you convert this into a normal distribution, Okay, if you convert this into a normal distribution, then NP becomes your mean, okay, and NPQ, which is the number of trials multiplied by the favorable multiplied by the unfavorable outcome, becomes your variance. Okay, so this is basically how you convert from binomial to normal. NP becomes your mean and NPQ becomes your variance. Okay, so this, as I've written here, becomes your mean, which is mu. Now, key point number 3, not just NP that must be greater than 5, but also NQ must also be greater than 5. Okay. Now, then have you guys heard of continuity correction? Yes? Okay. Now, have you guys memorized the rules, or have you guys memorized the rules? Okay, now those of you who are wondering what I'm saying, don't worry about it. If it's greater, we add 0.5. Yeah, that's correct. And if it's greater than or equal to, then we subtract 0.5. Okay, so what do I mean by that? Those of you who are doing it for the first time, don't worry, I'll explain. So basically, once binomial is converted to normal distribution, okay, there is something that is called continuity correction. Continuity correction is to be applied. Okay, so once again, a bit of a theory, but it's important for you to know. Okay, statistics starts to make sense when you do a bit of a theory as well. So the question is, what is CC? As in, what is continuity correction? Now, once again, keep this at the back of your mind that we're converting from binomial to normal distribution, and binomial distribution by its nature is of a discrete random variable, and normal distribution by its nature is of a continuous random variable. Okay, so let's write down the answer as to why we convert, and then we're gonna do two things over here. First, we're gonna look at the rules. Okay, then if you guys want, you can memorize the rules, or if you want, you can quickly figure it out there and then as to what you're going to do. Okay, there are two things that we do. We either add 0.5 or we subtract 0.5. Okay, now just by memorizing, the conditions may not make a whole lot of sense, but if you understand where they come from, then they will definitely make a lot more sense. So basically, binomial is possible when data is discrete. Normal is possible when data is continuous. To convert binomial, so basically to convert discrete to continuous, which is normal, we apply continuity correction. Okay, which I'm going to write as CC. Okay, now what are the rules? I'm going to write down the rules. All right, now do you guys remember IGCSE transformation matrices? You guys remember transformation matrices? Yes or no? I mean, I'm not going to be testing you over here, but do you guys by any chance remember? Okay, now there were two ways to go about those matrices. One was that you can memorize. Okay, you can memorize like the reflection matrix, you can memorize the rotation 90-degree clockwise, anti-clockwise, but there was another way, that is that you can figure it out there and then, as in you can come up with the matrix there and then if you just remember the basic rules. So how many of you memorized the matrices? Okay, so I'm assuming that all of you preferred figuring out or deriving the matrix there and then. Is that correct? Okay, brilliant. Now, so here is what we do. Now I'm writing down the rules. Once again, you're faced with two choices. Choice number one is that you can memorize them, and another choice is that you can figure it out there and then. Okay. Okay, now what does this mean? First I'll explain and then we'll see how we can derive it there and then. So basically, if you're asked to calculate, if you're converting from binomial to normal, okay, if you are converting from binomial to normal and you're asked to find out the probability of x being greater than a, okay, where a could be any value, all right, then remember what you do is you don't just take a when you're converting it to normal distribution, as in when you're using the formula x minus mu upon sigma, you, instead of taking a, you take a plus 0.5. Okay, and one thing to note is that in a normal distribution, whether it's greater than sign or whether we use greater than or equal to sign, it makes no difference because there's no separate treatment. So I'm just going to make one sign and we're going to stick to that sign only. Okay, so whether it's greater than or whether it's greater than or equal to, just like that, whether it's lesser than or whether it's lesser than or equal to, it has no impact in normal distribution. Why? Because it's continuous. In binomial distribution, of course, it has an impact. So if we say more than 3 out of 5, so that considers, that means 4 and 5 only. If we say at least 3, that means 3, 4 and 5. Okay, so now this means that if, for example, just to give you an example, and then we'll see where exactly this comes from. So if, for example, in a binomial distribution, you're asked to, you've converted from binomial to normal and you're asked to calculate the probability of x being greater than 4. So instead, what you will do is you will actually calculate the probability of x being greater than or equal to 4, or simply greater than 4.5. No need to write greater than or equal to, simply greater than 4.5. Now, the question is why? Why do we do what we do? Okay. So here is why we do it. The explanation is actually a lot simpler than you might think. Okay, now, if let's say we are solving a binomial distribution question, and we're asked to calculate the probability that x is greater than 4. Okay, that means we are going to consider which two bars? We're going to consider 5 and 6. Okay, that means we're going to consider the bar that I've highlighted in blue, which is 5 and 6. So once again, think of it this way, that you're tossing a coin 6 times and you're asked to calculate the probability of let's say you want to calculate the probability of getting 4 or more than 4 tails or more than 4 heads. So that means we're talking about 5 and 6. Okay, this is the area that we will actually calculate. Okay, but remember, when we are making a normal distribution curve, okay, when we're converting binomial to normal, then the values on the horizontal axis, like for example this point on normal distribution curve, where do we find 4? So this entire width is representing 4. Okay, this entire width of the bar is representing 4, but on a normal distribution curve, it's the midpoint of the width, the absolute midpoint of the width, which is representing 4. Okay, so if we are asked to calculate in a binomial distribution the probability of x being greater than 4, that means we're talking about 5 and 6. But if you look at the normal distribution curve, this is where 4 is. Okay, this is where 4 is in a normal distribution curve. Okay, and we are asked to calculate what? We are asked to calculate the probability. Remember, we're asked to calculate the probability of x is greater than 4. So as per the normal distribution, we are asked to calculate the probability of x being greater than this value. Okay, and what do you think this value will be? As per the normal distribution, we are asked to calculate the probability of x being greater than this value, which is in between 4 and 5. So that means it's 4.5. Okay, so the blue area basically comes after 4.5 in a normal distribution, which is why if we are asked to calculate probability of x being greater than 4, we will actually calculate the probability of x being greater than 4.5. Okay, now what's wrong with just leaving it as 4? What's wrong with just leading it as 4 is that it results, notice that the actual area, okay, notice that as per the normal distribution, this is the area, this is the area as per normal distribution, okay. Now, if we just calculate the blue area, then this results in what? This results in an underestimate. Okay, this results in an underestimate. So why do we do what we do? The answer is that because it results in an underestimate, which means that the probability will turn out to be lesser than actual. Okay, so if in a binomial distribution you're asked to calculate the probability of x being greater than 4, we instead calculate the probability of x being greater than or equal to 4.5. Okay, now that is for greater than. For greater than or equal to, let's see why we subtract 0.5. Okay, now I know this sounds a little weird that when it's greater we're adding, but when it's greater than or equal to, we're subtracting. Now this makes total sense if you go the extra mile and you understand why we do what we do. So if, let's say, you're asked to calculate the probability of x being greater than or equal to 4. Now let's see what that means. So greater than or equal to 4 means the bars that I've highlighted in blue. Okay, that means 4, 5 and 6. Okay, now as per the normal distribution, that means if you look at the normal distribution curve, this region actually starts from here. Let me use a different color so you can see the arrow clearly. This region actually starts from here. Okay, the bars that I've highlighted in blue as per the normal distribution actually start from here. Okay, now, and if we just leave it at 4, where do we find 4? 4 is basically over here. So that means if we let it be, if we don't convert it, okay, if in a normal distribution also we calculate x being greater than or equal to 4, then our answer turns out to be an underestimate. Why? Because we only end up calculating this area, okay, whereas the area that we're supposed to calculate, some area that we're also supposed to consider, we end up missing out on it, which is why instead of taking x is greater than or equal to 4, we take x is greater than or equal to 3.5. And why is that? That's because if we don't, it results in an overestimate. Sorry, it results in an underestimate, sorry. So that's why we take, if we're given probability of x is greater than or equal to 4, we instead take the probability that x is greater than or equal to. Again, in normal distribution, it makes no difference whether you take greater than or equal to. All right. Now, third case, the second to last case. No, actually, we have a few more cases. Okay. Now, here's the third case. If, let's say, let me erase this. If, let's say, you're asked to calculate the probability of x being less than 4. Okay. Now let me make some changes here real quick. Let me turn this screen. Let me turn this screen. Let me turn this screen as well. Now, as per the normal distribution, as per binomial distribution, less than 4 means all the bars that I'm now highlighting in blue. That means 3, 2, 1, and 0. Okay, the area of all these bars. Okay, that's what we have to calculate. Now, as per the normal distribution, where do these values start from? Okay, as per the normal distribution, they actually start from here. That means they are starting from 3.5. Okay, now what if we didn't convert? What if we let it be as it is? Then once again, here's what would have happened. As per normal distribution, 4 is here. Then we would have ended up calculating a little bit extra compared to what we want. Okay, and this would have resulted in what? An underestimate or an overestimate? Question for you guys. If I hadn't applied continuity correction, this is an additional area that we would have ended up calculating, and this would have resulted in an overestimate. That's correct. Okay, so why do we convert? That's because if we don't, in this case, this results in an overestimate. So once again, if you're given the probability of x being less than 4, you calculate the probability of x being less than 3.5. Okay, and don't worry, I know this may seem a bit overwhelming right now. What I'll do is, I'll solve a few questions, okay, where instead of just blatantly referring to the rules, we'll quickly figure it out there and then what we have to do. Okay, and you'll notice that it's not that difficult. You won't even have to make all these bars. You'll just have to make 3 bars, and that would be good enough. So now the second to last case, that is the probability of x being lesser than or equal to 4. So lesser than or equal to 4 means as per binomial distribution, lesser than or equal to 4 means 4, 3, 2, 1, and 0. So I'm going to have to make some changes over here real quick. Okay. Okay, so as I was saying, lesser than or equal to 4 means, I shouldn't have changed this color, 4, 3, whoops, 2, 1, and 0. Okay, this is as per binomial distribution. Okay, now see if you guys can answer this question. As per normal distribution, this region starts from here. Okay, as per normal distribution, this region starts from here. That's correct, 4.5. So what does that mean? That means that, what about if we hadn't converted? Then this would have resulted in what? What if we had taken 4? What if we had taken 4 only? Then this would have resulted in an overestimate or an underestimate? Underestimate. That's correct. Okay, why? Because we would have missed out on this area. Taking 4.5 means we don't miss out on any area, but taking less than 4 means we miss out on a small area. Okay, so why do we convert over here? That's because if we don't, this would result in an underestimate. Therefore, if you're ever asked to do probability of x being lesser than or equal to 4, we take the probability of x is less than less than 4.5, not 3.5. Okay, now the last case. The last case is interesting. What if you're asked to calculate the probability of x being equal to 4? Now once again, see if you guys can figure this out. Probability of x being equal to 4 means just 4. Okay, just 4. Oops. Now I'll make it slightly convenient for you. I'll highlight the bar that we want. Which part? Which part? Anya? This x is lesser than or equal to 4? Okay. Now, as per binomial distribution, lesser than or equal to 4 means what? 4, 3, 2, 1, 0. Again, think of it this way, that you're tossing a coin 6 times and you're asked to calculate the probability that you get a tail at most 4 times. That means 4, 3, 2, 1, and 0. Okay? But if you convert as per normal distribution, now remember, in a normal distribution, the point basically represents the midpoint of the bar. So this point where this normal distribution curve is made is actually the midpoint of the bar. Okay, so if we let it be as it is, if we don't apply continuity correction, we end up calculating only this area. Okay, the area that I'm highlighting in red, the area that's on the left side of the curve, left side of the dotted line. And you can see that we have missed out some area that we were supposed to include. Okay, we've missed out some area that we were supposed to include, which is why it's resulted in an underestimate, because some area is left out. Okay, now this is where 4 is as per the normal distribution. Okay, so what about this, where the bar ends and 5 starts? As per normal distribution, that's 4.5. So that means if you want this blue area, you should take it to be less than 4.5. Okay, if you take it to be less than 4.5, you end up calculating all the area that's on the left side of the curve, left side of this dotted line, the dotted vertical line that I've made at 4.5. Okay, that's why we add 0.5 here instead of subtracting. Okay, does that answer, does that help? Okay, now see if you guys can answer this. So we have an answer. No, it won't remain 4 after conversion. It won't remain 4. Now, there is no such thing as equal to 4 in normal distribution. Okay, it's either less than some value or greater than some value. So if you're faced with something like this, that means we now have to calculate the probability that it's in between these two values. And what are these two values going to be? As per the normal distribution, this value is 4.5. And once again, as per normal distribution, this value is 3.5. Okay, that means we have to calculate the area of the curve being in between these two values. Okay, and yes, Ubaidullah, your answer is correct. So what we're going to do is this. If we're asked to calculate probability of x equal to 4, we will then calculate the probability of x being greater than 3.5 and less than 4.5. Okay, what do we do about the left out region? Which region? There is no region that we're leaving out. Are you talking about the one that I've highlighted in green? The one over the normal curve. Okay, so see, this is not a scale diagram. Okay, this is not a scale diagram. And here you can see that the number of trials are 6. Okay, the number of trials are 6, which is why you might think that as per the normal distribution curve and as per the histogram of binomial distribution, there's going to be a clear difference. And you're right in doing so. Okay, you're right in thinking so. But normally what happens is we're dealing with scenarios where the number of trials are significantly large. Then there is no region that's left out. Okay, and even if there is, okay, we're estimating at the end of the day. Okay, we're estimating at the end of the day. So we're dealing with situations like these. Although we won't have 900 trials, but we will have close to, let's say, 100 trials or 80 trials or 60 trials. Okay, which is why, remember, at the end of the day, what we're doing is we are approximating it. Okay, we could use binomial distribution, but in a scenario like this would take forever. So instead what we do is we use normal approximation. Notice how this is not normal distribution. Okay, earlier what we did was we did normal distribution. Now the reason why this is called normal approximation is because that's what we're doing. We're taking binomial distribution and we're converting it to normal distribution, which is why, and because it's not going to be 100% accurate, we call it normal approximation. Okay, so earlier we did normal distribution. Now when you convert it, because it's not 100% accurate, you call it normal approximation. Okay. All right, now let's see how this is applied to questions. I'll do a few example questions, and then if you have any questions, feel free to ask. Okay, so here's a fairly recent question. Let's see what it says. It says in a large college, 28% of the students. So just so you know, the question will start like this. The question will be such that you will have a binomial element to it, okay, and then you will have a follow-up normal element to it. All right. So let's see what this question says. It says in a large college, 28% of the students do not play any musical instrument. Okay, you guys might remember solving the first part of this question. 52% play exactly one musical instrument and the remainder play 2 or more musical instruments. Okay, so what we do is, since we are talking about playing or not playing, okay, at least one means that they either play or they do not play. Okay, so here's what we're going to do. 28%, which means 0. Remember, we have to classify them into 2 categories. We don't want 3 or more categories. We're not interested whether they're playing 2, 3, 4, 5 musical instruments. We're only interested in whether they play a musical instrument or they do not play. Okay, so 0.28, pretty straightforward. They do not play any musical instrument. Okay, 0.52, 52%, that is, play exactly 1. Okay, they play exactly 1. And the remainder, which would be 80, 100 minus 20, 100 minus 80 is 20, that would be 0.20. These are the ones that play 2 or more. Okay, but like I said, we're not interested in 2, 3, 4. We're interested in whether they play or not play. Okay, so this is one category, that is they play. P for favorable outcome, because that's what we're interested in, right? We're interested in them playing a musical instrument. So this becomes 0.72, and the unfavorable outcome, which is not playing, remains 0.28. Okay. Now the first part is, how many students are we talking about? We're talking about 12 students. Okay, find the probability that more than 9. More than 9 means, in a binomial distribution, more than 9 means what? More than 9 means, so see if you guys can answer this question. Out of 12, more than 9 means what? How many students are we talking about? Out of 12, more than 9 of these students play at least one musical instrument. Let's see if you guys remember binomial distribution or not. 10, 11, 12, that's correct. So we'll consider 10 students, okay, we'll consider 11, and we'll consider 12. Okay, so what's the probability that out of 12 students, 10 play musical instrument? 12C 10. The probability of favorable, 0.72 to the power of 10, 0.28 to the power of 2, plus 12C11, probability of favorable, 0.72 to the power of 11, probability of unfavorable to the power of 1, plus 12C12, probability of favorable, 0.72 to the power of 12, probability of unfavorable to the power of 0. Okay, and then you will figure this out. Sorry, I'm actually not taking my class from my usual setup. That's why these mishaps. So I've worked this out already. The answer is going to be 0.3037, okay, which if you then give correct to 3 significant figures turns out to be 0.304. Okay, work this out as it is in your calculator. What I'm interested in is this following part. So don't think that there are two A parts to the same question. It's actually A part. It's actually two part A. Okay, that's why they're both part A's. Now, a random sample of 90 students from the college is now chosen. So from the same college, now we're talking about 90 students. Use an approximation. Notice how it says, it's hinting, it's telling you what to do. Use an approximation to find the probability that fewer than 40 of these students play exactly one musical instrument. Achha. Now, why is it not a good idea to use binomial distribution over here? Because if you think about it, fewer than 40 would mean 39, 38, 37, 36, 30, all the way to 0. Okay, from 90 all the way to 0. Or even if you work it the other way around, if let's say you calculate greater than 40 and then your plan is to subtract it from 1, or greater than or equal to 40, then you would do 40, 41, 42, 43. Yes, exactly. It's greater than 30. Okay, so trying to use binomial over here is not justified. Okay, even for 5 marks. Even if it was a 10-mark question, still not justified. We will just be able to do one question in the entire paper. So instead, what we have to do is we have to convert it to normal distribution. So that's what we're doing. Okay, we've decided that from binomial, we are converting it to normal. Okay, and this time it will be considered a normal approximation because we're converting it. Okay, so by nature, by default, it's not binomial distribution. It's not normal distribution, which is why we call it normal approximation. Okay. So what are the important values? Here are the important values. The number of trials, 90. The probability of favorable outcome. Okay, now what are we interested in right now? We're interested in exactly one musical instrument. Okay, that 40 of these students play exactly one musical instrument. That means the probability of the favorable outcome will be exactly one musical instrument. Everything else will be unfavorable. So the probability of favorable outcome is 0.52. Why is this favorable? Because that's what we're interested in. We're interested in exactly one musical instrument. Okay, so Q naturally becomes what? Q naturally becomes 0.48. Okay, now remember, if you're converting a binomial distribution to a normal distribution, then your mean and your variance will basically be NP, NP, Q respectively. That means if you want the mean, okay, if you want mean, here's what you will have to do: 90 into 0.52. Okay, so let's work this out, see what do we get. 90 into 0.52, that gives us 46.8. So that's the mean, 46.8. Just like that, if you want the variance, you will have to do NPQ. That means take the mean, which is 46.8, and just multiply it by Q, which is 0.48, and you get 22.464. 22.464. Okay, don't round this off or anything because it's not the final answer. So 90 into 0.52 into 0.48. Okay. Now, what do we have to calculate? We have to calculate the probability that fewer than 40. That means we have to calculate the probability that x is less than 40. Now, a lot of times, this is a very common error that students forget to apply continuity correction. Okay, so just make a note, CC. The second you see normal approximation, just write CC so that it prompts you to apply continuity correction. Now, if you remember the rule, brilliant. If you don't, that's even better. Okay, why? Because I'm going to teach you how you can work it out there and then and decide what you have to do. Okay, so and don't stress over this too much. It's very simple. Just make 3 bars. Okay, one greater than the value in question and one less than. Okay, so put 40 in between. Okay, after 40 we have 41 and then 39. Doesn't matter the order. Okay, like for example, although technically this is wrong because the mean will be at 46.8, so technically these bars should have been in ascending order rather than descending order, but it makes no difference. You will see how it makes absolutely no difference. Now what we want basically the probability of x is less than 40. Okay, that means this is the region that we want. This and everything towards the left, which as per the normal distribution, actually, sorry, we don't want this, we want less than 40, right? Which means we want, as per the binomial distribution, this is what we want. Okay, and this as per the normal distribution actually starts from here. Okay, this is actually 40.5. So that means what we have to do is we have to instead don't take 40, we have to take 40.5. Okay, wait a minute, just a second. 39, 40. We want less than 40 or greater than 40? We want less than 40. Okay, no, sorry, my bad. Less than 40. So this is 40, this is 39, this is 41. Okay, as per the binomial distribution, all right, I should have highlighted, should have followed the procedure. As per the binomial distribution, this is what we want. Okay, we want 39, 38, 37, all the bars before 40. But as per the normal distribution, we actually want it less than this value. And what will be this value? What will this value be? Will this be 40.5 or 39.5? This will be 39.5, exactly. So that means we are actually going to calculate the probability of x being less than 39.5. Okay, now I'll explain this again. So what's the value in question? The value in question is 40. Okay, now like I said, just figure it out there and then. Okay, don't waste your time trying to memorize all these rules. Figure it out there and then. Okay, so make 3 bars, one of 40. Okay, one of a value less than 40 and one of a value greater than 40. Okay, so here's 40, here's 41, here's 39. Okay, less than 40 means that we want the area of all the bars that are right before 40. That means we want the area of this bar, which is representing 39 successes, and all the bars before it. Okay, no need to draw too many bars. Okay, all the bars before it. Now, as per the normal distribution, what is this value going to be? As per the normal distribution, this value is actually not 40, this value is actually 39.5. Okay, so that means if you want to calculate less than 40, as per normal distribution, you actually have to calculate 39.5. Okay, so work it out like this, and with practice, you will understand how this works, and you won't have to waste a lot of time trying to convert it to normal distribution, trying to recall the rules and then converting and then applying continuity correction. Okay, so once this is done, then the next thing that you have to do is you have to use the formula. Okay, and what's the formula? Let's write that down. First, you will have to calculate the z-score, which is x minus mu over sigma. That means z is going to be equal to 39.5 minus the mean, which is 46.8, upon the standard deviation, which means square root of 22.464. Okay, so let's see what we get. So the probability of x being less than 39.5 is equal to phi of, let's see, 39.5 minus 46.8 over square root of 22.464 minus 1.540. Minus 1.540. Okay. Now what do we do when it's a negative value? What do we do when it's a negative value? We do 1 minus. That means we'll do 1 minus phi of 1.540. Okay. So let's find out phi of 1.540. Shaihan, no, we're not discussing the homework. We're learning conversion of binomial to normal. So 1.540, once again, I'm going to clear this. 1.540. So 1.5 is right here. 1.54 is going to be 0.9382. 0.9382. So 1 minus 0.9382. 1 minus 0.9382. How do we do this directly from the calculator? Yes, I am supposed to teach you that, right? Yeah, let me do that. 0.06. Yeah, I will do that. 0.0618. So there you go. Your answer is the probability that a student chosen at random from 90. The probability that you have fewer than 40 students, 40 of these students play exactly one musical instrument is 0.0618. Okay, I will teach you how to convert today only, inshallah. First, what I'd like you guys to do is, I would like us to do one more example question, and then I'd like you to do an example question, and then I'll teach you. Okay, I will teach you, don't worry about it. Here, you can skip the first part and do the second part. See if you guys can do this yourself. Okay, so I'll solve this question. 0.9863, let me check. No, I'm afraid not. It's actually 0.9472. 0.9472 is the final answer. Let's see. I'll solve this question and then you guys can check. So I'm just skipping. I'll do part A as well, although part A is binomial, but let's just do it. So we have to calculate the 1300 train from J to K runs every day. The probability that the train arrives late in K is 0.35. Okay, what are we interested in? We're interested in finding out the train arriving late. That means that is our favorable outcome, 0.35. So inevitably, the unfavorable outcome becomes 0.65. Okay, so we want to find out the probability of X being less than 3, which basically means the probability that the train is late 2 days, 1 day, or 0 days. Okay, since it's binomial, we have to consider 0 as well. So we start with 7C2, 0.65 to the power of 2, 0.35, sorry, the train is arriving late, yeah, 0.35 to the power of 2, 0.65 to the power of 5, then 7C3, 0.65, sorry, 0.35 to the power of 3, sorry, 7C1, 7C1, 0.35 to the power of 1, 0.65 to the power of 6, then finally 7C0, 0.35 to the power of 0, 0.65 to the power of 7. Okay, then you can work this out, whatever the answer is. Part B. Part B is what we're interested in. Part B says, use an approximation to find the probability that the train arrives late on more than 40 days. Okay, before that, a random sample of 142 days is taken. So immediately we know that's our Q that we have to convert it to normal distribution. Okay, so P is 0.35 and Q is, since we're still interested in the train arriving late, that means P and Q remain the same. So now the normal distribution will have mean NP and the variance NPQ. So mean, as you guys said, is 49.7. and the variance, as you guys said, is 39.305. Okay, now what do we have to find? We have to find out the probability that the train arrives late on more than 40 days. Okay, we have to find out the probability of X being greater than 40. Okay, how do we do that? So first of all, we're not just going to brainlessly use 40. We have to use continuity correction. So once again, make 3 bars. Okay, doesn't matter in which order. Just put the value in question in the center and have 2 values, one greater than the value, one lesser than the value. Okay. Now greater than 40 as per binomial distribution means you want to calculate the area of all the bars towards the right of 40, which as per normal distribution means the area of the region that's greater than 40.5. Okay, which as per normal distribution means 40.5. Okay, so I hope nobody forgot to apply continuity correction over here. So this becomes the probability of x being greater than 40.5. Okay, now so the z value, the z score, can be worked out by doing 40.5 minus 49.5 over the square root of 32.305. Okay. What is the z value? The z score turns out to be, let's see, what do we get? In the numerator, we have 40.5 minus 49.5. In the denominator, square root of 32.305. So we're looking at minus 1.583. Just a minute, let me confirm. 40.5 minus 40, yeah, 0.0528. Acha, hold on, let me see. 0.0528. Okay, maybe your answer is correct. Just a minute. What's the z value? Can anyone confirm the z value? Oh, 49.7. Yeah, 49.7. Sorry, that's why we're not getting the correct value. Yeah, minus 1.619. Yeah, so minus 1.619. Okay, now we have to calculate the probability of the z score being greater than minus 1.619. Okay, which basically means doing 1 minus, remember whenever it's greater than, we do 1 minus phi of minus 1.619, and because it's phi of a negative value, phi of a negative value can be worked out by doing 1 minus phi of the same value but positive. Okay, and don't forget the 1 minus. So ultimately we just end up calculating phi of 1.619. Okay, now let's calculate phi of 1.619. Let's see what that is. So 1.6, that's right here, 1.61. So 0.9463. What do we have to add in 0.9463? We have to add 9. So this becomes 0. Okay, let's not do it mentally. Let's write it down and then do it. So this becomes 0.9463 plus 0.0009. So 3 plus 9 is 12, 6 plus 1 is 7, 4 plus 0 is 4, 9 plus 0 is 0. So 0.9472 is the final answer. Okay, 0.9472 is the final answer. So patience is required, but conceptually it's pretty straightforward. The only trap that you can possibly fall for is not applying continuity correction. Okay, other than that, if you know binomial, if you know normal distribution, you should be able to do this as well. Okay. Now let me give you guys one more question. So in this question also, once again, we're jumping straight to the normal approximation part. Okay, I hope everyone's done. Now, since we have around 7-8 minutes left, I'm going to quickly teach you guys how you can use your calculator over here. Okay. Now, once again, as it is with anything that you can do in your calculator, make sure that you show you're working. All right. So even if your answer is correct, and you'll notice how, I mean, this is really something magical. You know, it's nothing short of magical, really. So once again, let me just prep things up. So I hope you have one of these calculators, Casio ClassWiz. I am pretty sure you can do it in some other calculator as well, but I am not too sure how. Okay, so for those of you who have one of these, I'll show you how you can use your calculator to do normal distribution. So first of all, what I want you to do is, I want you to press menu, and you'll see the bell curve. Okay, you'll see the bell curve. As soon as you press menu, you'll see it as 7. It works in FX991EX. I'm sure it does, but I just don't know how. Okay, because I've always used the class-based calculator. I mean, it's not difficult to figure out. I'm sure I'll be able to figure it out, but sadly, I don't have that calculator with me. Okay, so for those of you who have class-based calculators, press, where do you see the bell curve? Seven. Good. Okay, so press 7. All right. Then you will see normal PD, you will see normal CD, you will see inverse normal, you will see binomial PD, and then if you scroll down, you'll see binomial and Poisson and all of that. What we are interested in is normal cumulative distribution. So that's normal CD. Okay, so press CD. Okay, as you can see over here, we're interested in normal CD. Okay. Then it says lower, upper, and then you have a symbol for sigma. I use FX991EX. It's similar. Okay, if it's similar, then just follow along, right? So you will see these values, lower, upper, and then sigma, and then mu. Okay. Now, as far as lower is concerned, now here what you'll have to do is, since normally we don't write down the lower value, we just write down the value of one boundary, unless we're calculating the value in between two values, and that's what's given in the question. Otherwise, it's always greater than a certain value, lesser than a certain value. Okay. So, like for example, over here, this is x is greater than 40, which we then turned out to be, which we then converted it to 40.5. So that means what we're doing is, this is a normal distribution curve where the mean is right at the center. It's 49.7. Okay, and we are basically trying to calculate. The probability that x is greater than 40.5. Okay, so that means 40.5. This is what we're trying to calculate. Okay, I'm sorry for the hideous drawing, but I'm sure you guys get the point. 40.5. So we're trying to calculate all this area. Okay, we're trying to calculate all this area. Okay, so that means what's the lower limit? Since it's greater than 40.5, this becomes our lower limit. So where you see lower, I want you to write 40.5. Okay, where you see lower, I want you to write 40.5. Once you're done with that, as far as upper is concerned, since there is no upper limit, okay, so in place of upper, enter an extremely large value. Like for example, enter 10,000. Okay, 10,000, 1 million is not going to have an impact on our final answer. Don't worry about it. Okay, but make sure you enter an extremely large value. So the lower limit is 40.5. Since you want to calculate it to be greater than 40.5, let me use a color which is clearly visible. I think purple. Yeah, 40.5. The upper limit, just enter an extremely large value like 10,000. Okay. Then what about sigma? Sigma is the standard deviation. So what's the standard deviation? The standard deviation is square root of 32.305. So write 32.305. Make sure to close the bracket in place of sigma. Okay. Then what's the mean? The mean, as we saw, is 49.7. So write 49.7 here. Press the equals to sign and see the magic. You will have 0.9472. Send a picture of your calculator. Those of you are wondering if they have this function. You got 0.05? Okay, let's go back. Tell me what have you entered in place of lower? 40.5. In place of upper, 10,000. Okay, and in place of sigma, square root of 32.205, and in place of mu, make sure that you enter the mean, which is 49.7. If you've entered all the values correctly, you should get the correct answer. If you're not, you probably messed up a value or two. No other reason. Press the equals to sign, see what you get. Tell me if you're getting the correct answer now. 0.9472. Still not? Okay, can you share a picture of what you're doing? Can you share of all the... Okay, enough. In this calculator, do you see any normal distribution after you press mode? Enough. Do you see anything?
So, but I do see a stat option. I don't really see a distribution option.
You see a what option? Stats option.
Yeah.
Okay, what do you see after stat?
It's a bunch of functions, but when I press shift 1, I do see a few similar signs. One of them says distribution.
Okay. See, press distribution, see if you can find normal CD. Acha, I'm looking at, Rabia, I'm looking at your values. I don't see anything wrong. Okay, and once you scroll down, is your value of mu also correct? Because I don't see the value of mu, I'm assuming it's correct. Okay, that's interesting. That's interesting because I'm getting the correct answer. I'm getting normal CD. Okay. Enough, let me find out if it's possible in your calculator or not. Let me find out. Is it? Yeah, 0.9472. 0.9472. Not 6, it's 0.9472. You get that after subtracting from 1. Okay, wait a minute. I think I know why that is the case. Lower. No, that shouldn't be the case. That shouldn't be the case. 40.5. What about the rest of you? Are you getting the correct answer? Because I'm getting the correct answer. Lower is 40.5, upper is 10,000. Sigma is 5.6837. Mu is 49.7. I get the correct answer. Okay, Rabia. Okay, this is beyond me, honestly. Maybe. What brand is your calculator? It's Citizen. Maybe your calculator is programmed slightly differently because your calculator is not Casio ClassWiz, it's Citizen SuperWiz. So maybe it's programmed slightly differently. I don't know. I can't really say for sure. But this is how you do it. Okay, this is how you do it. That's another way. Another thing that you can do is, like, for example, if you want to calculate the phi value. Okay, so you can calculate the phi value as well. What you have to do is, like, for example, let's go back to one of the questions that we solved. If you want to calculate the phi value, do not change the what do you call, the mean and the standard deviation. Just let that be 0 and 1. Yeah, like for example over here we have the z value, which is 0. Wait a minute. Let me find a question where we can, yeah, let's take this one for example. Okay, so the z value turns out to be 0.6. okay, that means, here's what that means. The mean is 0. Okay, standard deviation is 1. 0.6 means something like this. So you want to calculate this area. Alright, so now this is 0.6 becomes the upper value. So once again, in the lower value, enter an extremely negative value like minus 10,000. In the upper value, enter 0.6. Now let the standard deviation be 1. Okay, and let the mean be 0. Do that and you will notice that you get 0.7257 only. Okay, so I repeat, the lower value, enter an extremely negative value like minus 10,000. Okay, for the upper value, the value in question, which is 0.6, let the mean be 0 and let the standard deviation be 1. Why? Because we are calculating the z value, and in a in a z table, the values have mean 0 and standard deviation 1. Okay, so practice this. Make sure that you practice this well enough so that you're confident of using it in the exam. Okay, you don't want to, this is something that you should use it to your advantage, not something that ends up confusing you. Okay, you should be able to figure it out and be confident that your calculator is giving the correct answer. And then once you actually figure out the correct answer, that should give you a confidence boost. Okay, so I'll stop here. I'll give you guys some questions to solve as homework. Tomorrow, inshallah, we will start permutations and combination. I will suggest a new calculator enough. I'll suggest the one that I'm using, Casio ClassWiz. You can't go wrong with this calculator. This one right here. I've always suggested this calculator because it has like all the features necessary. You're getting the correct answer by subtracting from 1. ऐसा होना तो नहीं चाहिए Rabia. Honestly, ऐसा होना नहीं चाहिए. I totally don't understand why this is happening. This shouldn't happen because this should happen if we change the limits. Okay, if we change the lower to upper and upper to lower. So maybe your calculator is not programmed correctly. Maybe. Okay. Khair. So I'll stop here. See you guys inshallah tomorrow. Tomorrow we're starting permutation and combination. Do not miss tomorrow's class. So take care everyone. Allah Hafiz. You just bought it? I'm really sorry. देखो calculators में ना, this is something that I would say for all of you. Just go with mainstream brands. Don't go with non-mainstream brands. Okay, Casio is a mainstream brand, so just stick to the mainstream brands. You can't go wrong with them. I know there may be like a significant price difference and they have become really expensive, but it's an investment. If you take care of it, they will last you for 5, 6, 7 years. In fact, I remember the calculator that I used in O-levels, I used it all the way through university as well. So yeah, just buy once, but buy original. Okay. Alright, so I'll stop here. See you guys tomorrow. Take care once again. Allah Hafiz.